This is Engineer Saman, and today I would like to show you how to control your flow level using PCU SIM. Now this stands for Process Control Unit Simulator, the simulator which is installed in your control lab in university, and it is connected with the demonstration equipment. Okay, just simply by starting this software, this simulator, you can control, you can see that on the main menu there are different systems. This system mimic is showing the complete components which is installed in this simulation software, and here we have flow control, temperature control, batch volume control, and fluid level control. Also there are other open loop control systems and other functions which we will further study. Today we'll discuss about only flow control. Now in flow control, we already have studied that there are two different methods. One is manually control system and other is automatic using PID control system. So before starting this, we will simply, in this control mode, we will select manual control system and uncheck this IND, which stands for integration and derivatives. Now this is start button where you can simply start our simulation. Here we have SP and MV. Now this is SP stands for set point and MV stands for measured value. Set point is the point where you want the desired output, and measure value is the received output, that which is actually working and actually received at the output. So for example, if you want your set point in liters per minute, for example, you have started a pump and you want that the flow rate is around 1.4, you can simply change the values over here. So the starting uh, point is set point is 1.4 liter per minute. Now it means that I want my pump to work in such a way that it will discharge only 1.4 liters in 1 minute. And here is set point. This set point is showing us that how to achieve your desired value in a linear system, linearly accelerating system, sinusoidal, or other increased, linear, or decreased, and both combination of both system. There are different types of behaviors to achieve your desired value, and this is here we will receive three bars which is showing us, which will be showing flow of set point, flow of measured value, and output of the pump. So let's I think we should start the simulation. Now the simulation is start, and we have the mode is control manual. So here you can see that this is our pump. We just by simply clicking on it, we have start our pump. Now you can see that the desired value is 1.4 liter per minute, and our pump, the green bar, is discharging more than the desired value. So here we have installed a gate valve which is completely opened at 100%. So we will close this gate at 90%, and you can see that the discharge rate is decreased. Now how this discharge is decreased? Because by closing this gate valve, we are just simply bypassing few of the liters through bypass channel. It's simply just closing the tab of your water, and the pump will shift that water to the bypass channel. So in short, we are just receiving 90% water flow out of the 100 of that pump, and the 10% is just bypassed in another channel. So you can see that we have still not received our desired value. I would like to close the gate valve. So the gate valve opening is at 80%, and you can see that we are we have almost achieved our desired value. Now this is not completely coinciding with this desired value, because you can see that by manually controlling these valves you cannot achieve your desired value perfectly, because manually you have to perform heat and trial method, and that is very difficult. So this is the manual system, and you can see that by opening the gate valve at 80%, we are facing through many losses. We are we are losing 20% of the work of this pump. Okay, the 20% of the liters per minute of this pump is just going waste, and that is simply circulating in our bypass channel, and again it is coming from drain pump uh, to the main driven pump. Okay, now I would stop the volume. Here you can see that this is set point 1.4 and 1.339 is the measured value, and there is 100% pump output showing by these bars. I would like to stop it and change the control mode to the PID control, and by default the value of integration and derivative 0 0.8 and 0, and I will simply just check these two boxes. Now you can see that changing the control mode over PID, we don't have manual option of pump to be open and closed, and we cannot increase or decrease the gate valve. Now, starting the simulation, now you can see that the pump valve was initially over here, and it is controlling itself in such a way that it would get the desired value, and that is simply achieved by using differential and integrating equations, which is already installed in the PID control mode, and that is working in the electric circuit, and that electric circuit is controlling the output value of our pump to just work as much as is required, and in these cases we are not having any kind of losses. So I hope you have understood these simulations much. You can also ask in the comments. Thank you so much.